protect my eyes. I don't want to go blind. And couple things. So what we're going to be using here is a boiling liquid. Okay, boiling liquid. What phases are we talking about? What states of matter when we say boiling? What's happening?
It's boiling.
Come on. Everybody didn't hear you. What'd you say?
Going from a liquid to a gas.
Good. It's going from a liquid to a gas. What do we know about boiling liquids? What can you tell me about boiling liquids? Yeah.
They're very hot.
Very, very hot, right? What does it take to boil water?
Heat.
Heat. How much heat? What do we have to get water to boil it?
Sunlight? Sun rays?
Not necessarily. You can evaporate water with the sun. What does it take to boil it, though?
212 degrees Fahrenheit or 100 degrees Celsius.
This guy's on point right here. 212 Fahrenheit or 100 degrees Celsius. Good job. Who knows what temperature that is in Kelvin? Anybody from my class, Ben?
273?
Close. 370. 370. Okay, so boiling liquids normally very, very, very hot, right?
Yeah.
Well, we're going to work with a different type of substance today, and it's called nitrogen. N2. Okay, nitrogen is in the air all around us. It's 80%, almost 80% of what you breathe is nitrogen gas. Now, nitrogen is a lot different from water because at room temperature, nitrogen wants to be a gas. So, in order for it to become a liquid, what do you think we have to do with it?
Melt.
Freeze it.
Freeze it. Well, before you freeze it, what do you have to do? In general, what do I have to do to a gas in order to get it to become a liquid?
Add oxygen.
Not necessarily.
Vaporize it.
It's already a vapor. Okay, so the nitrogen is a gas around us. How do we get a gas to become a liquid? What can we do, Jake?
You have to decrease the temperature and make it hotter.
We have to decrease the temperature, right? Okay? Gas particles have a lot of kinetic energy. They're moving around a lot. In order to slow them down and condense them into a liquid, we need to cool it down a lot. And so nitrogen is a unique substance in that it has a really, really, really low boiling point. So in other words, nitrogen wants to escape and become a gas at extremely low temperatures. And in particular, nitrogen boils at about negative 350 degrees Fahrenheit, which is really, 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 really cold. This morning it was like 5 degrees outside. That was pretty cold, right?
Yeah.
Okay, imagine that times 200. It's really, really cold. Very, very extremely cold temperatures. So, in other words, if I have nitrogen as a liquid, it's below that point. It's colder than that, because that's the point at which it will turn into a liquid. Okay? So what happens when you have things that are that cold, you can't just keep them in any old container. You have to have a special container for them. So, what we have here is what's called a dewar. Okay, right here, a dewar.
Hey, keep snapping. Be quiet.
A dewar is a special container, and it's kind of like the same idea as a Tervis cup or a Yeti cup, if you have one of those, but it's double-walled. So there's an outside and an inside, and in between the two layers, all of the air particles are vacuumed out. And heat needs particles to transfer through, so this keeps the liquid nitrogen really, really cold because the outside heat can't get to the inside where the liquid nitrogen is. So the container on the outside is room temperature, but on the inside, it's below 350 degrees Fahrenheit. Now, like we said, nitrogen is a boiling liquid. So, if I were to pour it into a container, it looks just like a boiling liquid.
Oh, we did it.
There's a lot coming up, but it's not in there.
There you go.
It's
Okay,
boiling
so if
already.
you can't see that, so we got lots of vigorous bubbling, And what that is that nitrogen turning into a gas, except it doesn't take hot